Hello, this is Morningstar, your instructor at College of Southern Nevada. If you're watching this video, you're in my class CAT 173, Introduction to Linux. Today we will discuss Chapter 6 of Red Hat Linux Administration, and we'll learn how to manage local Linux users and groups. So first of all, let's cover objectives for this chapter. The objectives, by the completion of this chapter, you will be able to explain the role of users and groups in Linux systems and how they are seen by the computer. Run commands as a super user, switch commands, and run as administrator. Create, modify, lock, and delete locally defined user accounts, and create, modify, locally defined group accounts. And additionally, you will learn how to lock accounts manually or resetting passwords. Let's talk first about what is user. User is any entity that registered on the Linux or any operating system machine. But since we're in a Linux class, today we're going to talk about Linux only. Users can be different types. Administrative users usually called root in Linux, and by now we already know what root does. All administration on the computer, installing applications, removing applications, running scripts would require you to have root capabilities, and any user on the account will be able to perform this under root privileges if they will run as a root. Later, we will see what the user can do about that situation when they don't have any administrative rights. So any other user on the system doesn't have any abilities to change the system itself unless they run as a root. So there are three main types of account users: root, and usually user ID for the root would be 0, and system user accounts, which is anybody else on the computers, and usually they're running some kind of processes. They can perform operations with the system, but they cannot make any dramatic changes to the system. And regular user accounts, day-to-day work. So we have not discussed yet what are processes, but later in a few chapters from now, we will actually work with processes more closely. However, right now you need to understand that every process is the running program. And this running program, they also need to be performed by some type of user entity. And depending on what this user entity privileges are, there will be assigned different groups to these users. Let's just say in a basic example, I'm not administrative user on the system. I'm just a regular type of user, but I need to get access to the shared folders and files. So I will need permissions to access to these resources. And the best way to do this would be assign my account into the group, because most likely my user account is not the only user account that would need these permissions. And we will see this in a moment. ID command will actually tell us who we are on the system. So if we run ID command, we will get information regarding our own user ID that we currently logged in. So if we run ID on this specific machine, as you can see on the screenshot, it's user ID would start with 100, and the name of this user would be teacher. Group ID also in a group of teachers, and we will explain a little later what it is, but basically it's something that related to Red Hat. And then we can also see through this different permissions that we will be able to perform on this computer. If we will run simple ls command, we will see, like, for example, for the file, what we can perform on this machine as a user. For example, file 32.txt, we can see that in the second column, we see that we can read and write. And we also can see that we are owners of this file. So file permissions, it's something that we need to understand how they work. And at this moment, we can see that our group also can, teachers group can perform read and write on this file that located on the system. And the rest of the group, the others, can only read this document. And on the bottom, you can see LSLD, and we can see who is the owner of directory. So LSLD of the documents directory is the teacher user. All right, let's move on. Now, we also will be able to view running process on the system currently. And to see running processes, you will use command ps. There are different options listed on this slide that you can use to run processes. For example, when you're running processes with option A, you will view all processes within terminal. And if you will list both of options A and U, you will also see not just processes, but users associated with these processes. Sometimes it's really important because different users might start different processes, and you need to figure out who is running what processes. And if you remember, there are 3 different groups. As regular users, we also can start processes, but one of the groups is programs or different applications that need to start processes, and they also considered as the users of the system. Okay, now I want you to make a note that etc passwd is a directory that contains information about the user. So if you remember, passwd is the command that helped us to change a password for the user, for the current user at that moment. And if we will proceed into etc passwd, we will be able to see information about the current user, unless we have privileged access and we can see all users that on this system. So at this moment, we see user 01 on the screenshot, this example from the book. So let's break it down. First, we will see username. At this example, it's user 01. In the second field, where you can see X, it's user password to be stored here in encrypted format. So X would be stand for encrypted format. And as you can see, it also says that this field should always be X. The UID stands for user ID. And if it's regular user account, it's here starts with 1000. Then we see a group ID number, and since it's user's account primary group, it would be also 1000. And again, we will discuss groups later. And the real name of the user. So we often don't use our real name, but here we just say it's user1. The home directory for the user would be under number 6. And if you remember, it's always directory starts with home and our user ID name, most likely. So it's something that's not new by now for you. And then we have another under number 7, default shell. So basically, from where we will use our settings for our shell. And I want you to quickly take a look at the screenshot on the bottom. And here we use cat command with tail for one line only to see your username at the end of the file. So we just cat the directory etc passwd, and you will be able to do this on your own system, virtual machine, or in MATLAB. You can just run cat command and you can see your own users. So in this example, on the screenshot, my user ID would be teacher. My password is encrypted, and again, it should be always be encrypted. User ID 1000, user group ID also 1000, and the name of the user, like real name as it's stated, would be teacher, and home directory home teacher, and my shell would be located in my settings of the shell would be located in bin bash, just as it's in previous example from the book. Okay, so now let's see another example of etc group. So etc group directory, or file basically in etc directory, contains information about the group. So if we will go back, if we need to find information about users, we will go to the passwd. But if we need to find out about group, it's going to be group file. And we can find out information about group, and here how information looks for each individual group. So here again, example from the book. You can see under number 1, it's a group name, and group password. Yes, it should be protected by passwords, and passwords should be encrypted again. Under number 3 is group ID, and then list of users who are using this group. So remember how I told you at the beginning of this lecture that multiple users might need access to the same resources. How we will provide these resources for them and make sure only users who are authorized to get this access would be able to get authorized. We will create this group. So that's how we can see what group and what permissions of this group are. Primary groups and supplementary groups. So basically, every user has a primary group where this user is assigned. And we already know how to check in what group user belongs and what would be a group ID. And as it stated, primary group owns all new files that created by user. So if I'm a user teacher and I belong to the group teachers, every new file that I would create on the system will belong to this group. Supplementary groups, sometimes it happens when a user needs to get access to some different groups. These groups will not be primary. It will be called supplementary groups. And we also can see this in etc group when we are checking groups, and we can see all users that have access to the supplementary groups. How would we get super user access? We already discussed this in the past lessons. We will need to act as a root. So if we need some elevated permissions on the system, for example, we need to install new program or run a script, we need to perform this as root. And if we are not root at the moment, we can switch to be root. So here on the screenshot, you can see how we use su command. We also discussed this in the past. If we use sudo, which stands for super user do, and then we will put su at the end with the dash, we will switch into the user account. I want you to make a note that you will be prompted to enter your regular password for the teacher account. And if we need to act just the root but without switching to the root account, we will actually just do sudo and then command, but we also will be prompted to enter the password. Just repeating again, SU stands for switch user, and we not always switch users to root. So if we want to switch to any other user that using the same system, the same operating system as us, we can just use command su and then type the name of the user. It's important to mention that SU username starts at non-login shell. So basically, that's not our actual login. And if we do SU dash, that will be a real login shell. So we will act as an administrative user at that moment. Okay. Here a little bit more about information regarding su command. So we're switching to the different user, and if we're just running to sudo su, we are in the root. Basically, we have administrative rights on this computer, but without login shell. And same with su teacher, we're just switching to the teacher account. And we already did it before, but to refresh your memory, when we need to run commands as root, we use command sudo. So super user do, easy to remember. And you remember that root can do pretty much everything on the system when other users can do nothing, system related. And if we check a directory etc sudoers, that's where we will find all the commands that can be run as a root. And difference between su command and sudo, basically su will let you just switch in between users, but sudo will require you to enter your own password, but you will be able to perform some administrative rights. So just think about su as switching user. So you can switch to the root and be as a root. But with sudo, you're not switching to another user. You're running as yourself on the system, but you will be gaining administrative rights to the system. All right. So another important line here on the slide, I want you to pay attention to the bottom of the slide, that all the commands that you perform with sudo will be logged in var log secure. It's really important because when you do administration of the system, you often need to consider logging information. So you need to see who did what, and when users ran as super users commands, you also need to see what changes had been done on the system. So will group node. So that's something only related to the Red Hat. And here it's mentioned only 7 and 8 because this is slightly little outdated. Right now we're working in the 8.2 system. And that's not something that you can do in Ubuntu. Ubuntu doesn't have a group will. So in a group will, users can use sudo to run commands as any user of this will, including the root. And here how we can get interactive root shell with sudo. So basically we are running as non-administrative user, but for some reason we need to run a command that would require us elevated privileges, right? And for that we would use sudo and we will switch to root. So if we just do sudo su dash, that will allow us to switch to the root and basically become a root of the system, become administrative account on the system. And there are two more commands that you need to pay attention. Sudo I. Sudo I will switch to the root account and run that user default shell. And sudo S will just run the shell. And we also can change some sudo commands. So we already talk about etc sudoers. That's the list basically of all the commands that's being run with sudo. And this can be only edited with vsudo. So we can basically it's same vim text editor, but without administrative privilege, we will not be able to make any changes to this file. And by default, it's also any content of files or anything in sudoers will be included in this directory. So we can change configurations of this file, and that's what allows us to have different privileges for different users who run sudo command. Because if there are no limitations on sudo command for all users, then pretty much anyone would be able to act as a root and gain administrative rights. So this would be something important to remember when you're administrating Linux system. Now, here's some commands that we will use today to manage local users. So we will add users with user add, we will delete users with user del, and basically, if we use command user del with username, we will remove the user from the etc plus wd list, but the directory, the home directory and everything, all files in it would be still remaining. If we will use R option, which stands for recursive, we will remove not just user, but anything from the directory that comes with this user account. And user mod basically modifies existing users. Here are some different options that we can use with user mod. So C or comment, we will add the value like full name or anything else to that, basically additional information as a comment. G or GID group, that's where we can specify to what group this user would belong. And by the group using group ID, and upper G or groups will specify a list of supplementary groups. So we remember we have primary group that we can identify by GID, group ID, but we also can be using supplementary groups for users. A or append, as you can see, it says used with the G option, which is supplementary group, and it appends the user to the supplementary groups. And D or home under score dir, there are different options, but they all perform the same thing. And easier to remember D, of course. It specifies new home directory for the user. So our home directory that starts with home is not always should be the case. Sometimes we can change our home directory if we need it. Now with M or move home, we can move home directory. Let's just say we need our home directory in a different directory itself. Then as for new shell, when we need to open new shell, and L, and again, that's something we will discuss at the end of this lecture, it would be an option that will help us to lock user. I want you to understand log doesn't mean delete. Lock, it means remove access for this user at that moment. And with U option, we can unlock the user. All right, we already done it in the very first lecture, pass WD to change the password. And user can change the password for themselves, and root can change a password for any user on the system. User ID. So here a little more in details about user ID. If user ID is 0, so we're running ID command, and we see that we have user ID 0. We know this user is the root user. It has administrative rights. If we see UID from 1 to 200, it's usually system users. So users that running the system, they opening different programs, and they running different processes at that moment. So they're going to have UID between 1 and 200. And UID between 200 and 999, it's a system users. Again, that's the group of users that's starting processes that's necessary for the system. So the difference between UID from 1 to 200 and from 201 to 999, in the first group, it's going to be system users, which is similar to the second group, but they assign statically. The second group is not static, it's dynamically changed. So the same user ID will be assigned to the different processes if it's not static group. And regular users like you and I, when we're using our Linux system, would usually have any UID starting with 1000. So 1000 plus is the range available for assigning just regular users. Okay, we as well can use our management for group accounts, because sometimes it's easier for us to modify entire group than individual users. What if we have to limit access to some resources to multiple users? It would be easier for us to create a group or modify the group, existing group, the way we need users of this group to access different resources in the system. Let's just say I have users that belong to the group accounting, and they have access to all accounting files. But then I will create separate user group that would have access, for example, to all taxes. So I don't want all of my users from account group to access to this taxes information. And with modification within the group itself, we would be able to limit certain users from access certain information that belongs to the shared resources. So again, it's similar to the user commands. It's going to be group add, where you specify the group name. And as you can see, the JD for the range of groups will be in the login.def file. With lowercase g option, we will be able to specify specific group ID for the group user when we're adding this user group. And group mode specified, well, basically you can modify the group with this. And group delete similar to the user command. And user mode that we already discussed in the previous slide, it helps us to alternate the options for the user, not for the group. But why it's here? Because with user mode, we can actually make this user to be member of different groups. Okay, here is important information for you to remember in general. So we don't keep our passwords for users in a list in a file that passwd. etc passwd directory has password policies, basically information regarding the user. And shadow will have information regarding that password, but not the password itself. And I will explain you in a moment how it works. But right now, what you need to understand, we should never keep users' passwords in the plain text. passwd file does not have user passwords at all. And shadows has information regarding the passwords. So basically shadows of the passwords. And let's see all different fields of this information from passwd. So first we will see user of the account the password belongs to, so username. Then encrypted password of the user. And this password is actually not encrypted. This is incorrect information from the book. It's hashed. The password we keep in hashed form, not encrypted form, but they use hashed as the encryption as analogy here, because we did not really learn yet the difference between hashing and encryption. So hashing as type of encryption at this moment. And then under number 3, you can see that is actually interesting information. So that's the day of which the password was last changed. But how would you know what day it was last changed? Basically, in Linux system, you calculate the date based on the epoch time. So the date 1970, January 1st of 1970 would be your beginning of time, your epoch time. Epoch, you can hear different pronunciation of this depending on what country you are from and what country you're using this. But that's a Linux time. On the right, I posted extra information regarding this. I would suggest you to Google it and learn a little bit more. There are epoch calculators online available if you need to, for some reason, calculate current date and time into the epoch time. So what is epoch time? Another name for this would be Unix time or Linux time. It's point of time. It's nonlinear point of time, and it's basically a number of seconds that passed from the January 1st of 1970 at 000 by UTC, Universal Time Format. And it's often used by all operating systems because for computers it's easier to calculate in seconds than actually using actual dates. And number 4, the minimum number of days that have to elapse since the last password change before the user can change it again. So at this moment, it stays at 0. That means user has to change the password at the moment of login. The maximum number of days that can pass without password change before it expires here stands at 99,999. But basically, it's the way in Linux say it's unlimited. So number 6 would show us the warning period, basically how many days in advance user will get a warning that this user needs to change the password. And number 7 will show an activity period. So once your password is expired, it becomes inactive, so your user account will not be accessible. And for some reason, I just went all the way to the back. Your user account will no longer be accessible. So it's really important to set up a number of days within what time frame users still be able to change the password, which is under number 6. But also, we need to monitor how many days passed since user have not changed the password on time. And passwords also should be expiring. As you can see, you can set the time in epoch, basically in seconds or days since 1970. And yeah, it's also all in UTC time zone. That's another information that you need to understand, memorize, that in order to have some kind of universal time, we would calculate time in UTC, and then we will, based on our location, adjust to this. And if we have like any empty field, means it does not expire particular dates. But if we have something under the number 8, that means there is the expiration date for the password. And as you can see, 9 is empty field, and because it's reserved in the future unless we decide to make some changes. Okay, encrypted passwords. So it's really important to understand how operating systems encrypt passwords. And again, encryption is not exactly the way we saving passwords on the system. We actually saving encrypted hash. So first, user enters the password, and system would hash this password and then add the salt to this password. And salt is just a little bit of information and at the end of the hash that will identify this user's password as it belongs to this user. And later in example, we will see why we need salt. So it's pretty simple. You can see on this screenshot from the book. For Linux Red Hat, common hashing algorithm is SHA-512. So the password will be hashed with the SHA-512 hashing algorithm. And we will hear different hashing algorithms in the future. but you need to know that by default, Red Hat should use SHA-512. The salt is used in the encrypt password. So basically, we're adding this information so you can see at the number 2, it starts with the $sign. So that's how we'll separate the hash of the password and the salt itself. And number 3, that would be the encrypted hash of the password and the salt. So when user tries to log in into the system and enter the password, this password will not be saved on the system. What happens? It happens this mathematical algorithm when the system just remembers the hash for the password and the salt that added to this hash. So that makes breaking passwords not easy. I also will add a lab to you this week where you will be able to see how breaking passwords actually work. Again, this lab is not required. That's something you can just practice with. And you will better understand how hashing and how breaking passwords is actually possible and how hashing affects this mechanism. So if you have very strong password that doesn't have well-known hashes in the system, it's nearly impossible to break your password. That's why we continuously try to educate our users on using complex passwords. Okay, where we will see the list of these passwords. Never we will see the list of the passwords, but the hashes of this will be saved in the shadow file. So password verification. I'm entering my password when I'm trying to enter the system. And on the background, operating system will compare the hash of my password that I entered to the existing hash in the shadow file. And if they match, the system will let me in. If it doesn't match, I will not be let into the system, and it will tell me, oops, wrong password. I also forgot to mention, no, I didn't. We actually going to be with this algorithm. If we're using two different, user accounts, but for some unknown reason, user 1 and user 2 have exactly the same passwords. Let's just say user 1 is using password word as a password, and user 2 using password word as a password. How system would identify what user needs to log in, what user is using actually their own password? The salt will tell. So added salt is actually will identify two identical passwords from each other. With change command, we will be able to modify a different aging policy for the password. So basically, remember we discussed just recently about that user needs to change the password at the login. So we can set up with the change -d option and 0. 0 means at the first login, user will be prompted to change the password. If we will put 1, that means user will be able to log in first time with the assigned password, default password, and on the second time we'll be able to change. So that's how it works. And change -L will list username's current settings. So we need to see different users' settings, right? We will run command change -L, lowercase l, and we will see what assigned policy to the user. Then, this little complicated, so I want you to pay attention. With change E and then the date, we can set up when the account is expiring. For example, we have temporary user who needs access to the system only for a couple days. Then we will use change command with option E, and we set up the date in 2 days from now, and this user will have access only today and tomorrow, and after a certain date, he will no longer have this account. It will expire. How we will restrict access? We already a little bit discussed this, that user mode -L or another command that will perform the same ability to restrict user to access to his account would be passwd-lowercase-l. So you have to remember you can use each of these commands, but they will do pretty much the same restriction. So with this command, you sort of lock user from accessing his system, his user account. And another command that we will need to understand is user mode, when we can modify different options for this user. But I want you to pay attention to the bottom of this slide, where command passwd, the command that we use to change passwords, with the status option and then username. For example, we administrative user on the system, and we need to see if the account is locked or unlocked. We will use this command. So if we see flag LK at in the output, that means the user is actually locked. So we're performing a locking user with user mode -L and username, and then we have to verify this information. No login shell. So sometimes we not just need to log the user, but disable account. And the best way would be this to disable with the sbin no login file, because we will just add this user to no login file. That means this user has no longer option to log in into the shell. And if you remember, with the shell, we can do a lot of modifications, even as regular users who runs as a sudo. So we won't restrict users to accessing shell. That's the command user mode. Option S, then we have to specify directory sbin, file no login, and then we will specify the username that we want to add to this list. Okay, and today we learned that Linux has 3 main types of user accounts: super users, system user, regular users. We know that users can be part of the groups, and all new users will be assigned their primary group, but they also can be users of supplementary groups that have different additional access to resources and perform different additional tasks on the computer. And there are really important files and directories that need to be known by Linux administrator, such as etc passwd, that contains information about users on the system, etc group, that contains information regarding any groups on the Linux system, and etc shadow, that has a list of hashed and encrypted passwords. And we'll learn that with su command, we can switch user to pretty much any user on the system. And with sudo command, we can run as a root on the system. Commands user add, user mod, and user del to manage users on the system. Group add, group mod, and group delete. group del commands to manage groups. And if we need to configure passwords for users or locked users, then we will use configure password policies with the change command, or we will use passwd to actually see the current state of the user. Okay, thank you for watching this lecture, and now we can proceed to our labs.